Okay, so we are told that this person measured a rectangular prism to be 5 centimeters by 8 centimeters by 4 centimeters, but the actual measurements are 5.3 by 8.2 by 4.1 centimeters. They want to know what the relative error is to the nearest thousandth. So first of all, let's find what's called absolute error, and that's just a way of saying, hey, subtract your observed value, that's the measurements you took, right, the observed value, from the actual values. So that's the values that you should have gotten right here, which are these values. And they call it the absolute value because sometimes your observed values are higher, sometimes they're lower, but when you subtract them, you're always looking for a positive difference. So really, you want to know how far off you are. So here, what I'm going to do is I want to actually calculate the volume of uh, the observed values. So we get 5 times 8 times 4, and that's just, right, 160. So we got this person got 160, and they should have gotten this number right here, which is 5.3, calculated 2, by 8.2, oops, 8.2 by 4.1. And that's 178.186, 178.186, and that's the actual value. That's what we should have gotten, but what we observed is right here. This is the observed value. So, I mean, in one sense, for volume, right, and they want the relative error in the volume, it's just this difference between these two are 18.186, right? And then the relative error says, all right, well, you know how far off you were, right? But what did that really matter? So the relative error writes this as a ratio, where you do the absolute error, we just found that, 18.186, over the actual value. In other words, how much off were you out of the total, as almost like a percentage here. So we do the 18.186 divided by, can we call that last problem? We get 0.10206, 0.10206, and so forth. But we went to the nearest thousandth, 10/100th thousandths, so that equals, right, 0.102. That's our answer. Moving on, to calculate the volume of a small wooden cube, Ezra measures the cube. Each edge of the cube is 2 centimeters, but the actual length is 2.1. Same process. First, we want to find the absolute error. That's how far off you are from what you should have gotten. And we're looking at volume, right? So we should have gotten 2 by 2 by 2, or 8 centimeters cubed. We get 2.1 cubed, so 2.1 to the third power, and we get 9.261. 9.261. We're taking the absolute value though, so we'll get negative here, 1.261. We're taking the absolute value of that, so it's the positive. It's always the positive distance, right? How far are you from what you should have gotten? But relative error is just that number out of the actual. In other words, how far off were you out of the total? So 1.261 for what should have been 9.261 cubic centimeters. And what is that? I don't know. Let's see. So 1.261 divided by that answer from before, which is 0.13616. 0.13616. Get that right? Okay, and then it's the nearest hundredths, so 0.13, or 0.14, sorry, because this 6 is how we round the 3 up, so 0.14. Okay, moving on. Jack wants to replace the flooring. He calculates the area to be 12.8, but he should have gotten 13.5. What's the relative error? Okay, so absolute error is the difference between what you should have gotten and what you did get, but it's an absolute value, so you always get a positive value. So we did 12.8 minus 13.5, or the reverse order, doesn't matter. We're just taking the absolute value. And this equals what? Well, it equals negative 0.7. Negative 0.7. But it's the absolute value, so it's 0.7, right? And that 0.7 as a relative error is as a fraction. So 0.7 out of the actual amount, which is 13.5, right? So it's like a ratio. So it's 0.7 divided by 13.5, and we've got 0.05185, right? 0.05185. And to the nearest thousandth, we have 10 100,000. This 1 should be rounded up to a 2 because of this 8 right here. So I pick choice 2. Next one, an oil company distributes oil. And the actual radius is 5.1 centimeters and the height is 15.1. The worker incorrectly measured the radius is 5 and the height is 15. Determine the relative error. So, first of all, we're looking at surface area here. It tells us the surface area. Remember, that's 2 pi r squared plus 2 pi rh. And all that is it's 2 pi r squared, remember, because that's just two circles. 2 pi rh because it's circumference times the height, or that rectangle that wraps around the shape. So we want to find out, first of all, what is the actual value we should have gotten. So it should have been 2 pi times 5.1 squared plus 2 pi times 5.1 times 15.1. Right? That's what we should have gotten. Let's see what that is. So here, 2 times pi, second exponent for pi. Okay, press enter. That's being multiplied by 5.1 to the second power. And that's 163.4. And you don't have to write it down, the calculator will keep track of it for you. Plus, now I'm going to enter all this in a string. 2 times pi, I'm just following this right here, times 5.1 times, times 5.1 times 15.1. That's everything together, 647, right? 647.29, 375.03. This is what we should have gotten for surface area. But what did we get? We got 5 by 15, so we would get 2 pi times 5 squared plus 2 pi times 5 times 15. Let's see how off this is. So here we have 2 times pi times 5 times 5. Oops, it's not working. Fix that. 2 times pi, right, times 5 times 5, enter, plus 2 times pi times 5 times 15. Okay, so here, this tells us we should have gotten 628.3185.307. Okay. So we're just going to subtract the two. 647.29.375.03 minus 628.3185.307. Okay, that's our difference there. That's our absolute value, but it should be out of the actual value, what we should have gotten. So divided by 647.293, right, 7503. So that's a relative error, 0.02931. They want the nearest thousandth, so that's 10 100,000th, 0.029. So 0.029 just means that's how far off we were in comparison to what we should have gotten. And these kind of problems repeat themselves here. Again, we have the dimensions of a rectangle here, 12.2 by 11.8. But we should have gotten 12.3 by 11.9. What's the relative error? Okay, so for area, we should have gotten 12.2. No, we should have gotten 12.3 by 11.9. So that's our actual. Let's find the area. 12.3 times 11.9. This is the actual area. 146.37. So the actual is 146.37. What is the observed? The observed is 12.2 times 11.8. Okay, 143.96. Alright, so the absolute error is the difference between these. That'll be our first step here. So we want to do 146.37 minus the previous entry, second answer. We're off by 2.41, but it's out of the actual amount, or 146.37. So we divide that by 146.37. You have 0.0164. We're not to the nearest 10,000th, so it's 10 hundred thousandths, 10 thousandths. It's 0.0165, right? This 6 rounds the 4 up to a 5. So here we get choice 3. Okay, moving on. Alright, so here, more relative error problems. And we should have gotten the dimensions to be 6. No, we did get it by 6, by 10, by 1.5. So that's our observed, right? Observed values for volume. It's 6 times 10 times 1.5. And the actual that we got here is 5.9 times 10.3 times 1.7. So here we can compare the volumes. So 6 times 10 times 1.5. This is our observed value, or 90. But the actual is 5.9 times 10.3 times 1.7. So we should have gotten 103.309. So now relative error is your observed value, right? Sorry, the absolute error is the difference between these two, which is 13.309. So the absolute error is just the difference of the two, and make sure it's always positive. In the end, should be 13.309. But the relative error it uses the absolute error. Relative error just says, okay, take the absolute error and write that out of what you should have gotten, the actual. So we have our absolute error right here. We have our actual right here. We just do one over the other. So we do 13.309 divided by 103.309. And this will be our relative error, 0.1288, 1 to the nearest thousandth, so 0.2129, right, 10 hundred thousandth, 0.129. That's our relative error. Okay, next one, actual dimensions, but here's what we measured, what's the relative error. So, right, we should have gotten 2.6 by 6.9, we had 2.5 by 6.8. We want to know what's the relative error in the area. 2.5 by 6.8, 6.8, that's what we should have gotten, which is 17. Okay. And, that's the observed value. And 2.6 by 6.9, 2.6 by 6.9 is 17.94. Okay, what's the relative error here? So if we subtract these two, we get 0.94. That's how far off we are. But it should be out of the actual to find the relative error. So it's out of 17.94. That'll tell us kind of how far off we are in a sense. So it's 0.94 divided by 17.94. 0.0523 to the nearest thousandth, 0.052. That's choice 2. Okay, keep going here. Okay, so we're going to the relative error because here the students calculated 8,100 square feet. So that's the observed value is 8,100 square feet. But the actual value is 7,678.5 square feet. What's the relative error? Well, we would subtract these two. So I'll do 8,100 minus 7,678.5. We have 421, right? 0.5. Okay, so the relative error is that absolute error out of the actual number you should have gotten. So it's 742.15. Let's check the number. So it's 421.5 over, right, what you should have actually gotten. So here it's a ratio over 7,678.5. So we've got 421.5 divided by 7,678.5, a 0.05489, 10/100,000th, so it's 0.055. If I want to turn it into a percent, I multiply it by 100 and get 5.5%. Okay, so we calculate the area of paper to be this, but the actual is this. What's the relative error? So if we subtract the two, we get the absolute error. That's the first step. So 55.42 minus 50.27. Okay, so that is the absolute error. Oops. Or 5.15. But that should be out of the actual amount. So the actual error is 55.42. So this number, right, 5.15 divided by 55.42. What do we get? 0.092, nearest thousandth, 0.093. Choice 2. Which value makes the expression undefined? These are great because undefined means the denominator equals 0. You can't divide by 0. So if x was 3, you'd have 3 minus 3 here, or 0, and you'd be dividing by it. So x can't equal 3. Okay, next one. What would make this undefined? So if you're struggling, right, again, this is just going to be equal to 0, so you do 2, right? When does 2n minus 1 equal 0? Add 1 to both sides, and 2n equals 1. So then you can see divide both sides by 2, and equals 1/2. Right, so that's choice 4. Choice 4. Okay. All right. Okay, last problem. When is this undefined? Well, this one's a little bit tougher because it involves quadratics, but once we get the hang of that, it's quite simple. So when would this be undefined? Well, this is something called the difference of two squares, x squared minus 4. That always equals x, the square root of this term, plus the square root of this term, right? Parentheses x minus 2. So here we've factored it out. What that tells us is if we have 14 plus x, and then x plus 2 times x minus 2, if x equals 2, then you can't plug it in here. If x equals negative 2, right, then you would have to plug it in here. So those don't work. Also, so here we go with negative 2 or 2.